Good afternoon, sir. So this afternoon, I would like, or I'm going to discuss about the thermodynamic system. So first, what is thermodynamic system? So thermodynamic system is a system refers to definite quantity of matter most often contains within some closed surface chosen for study. So here is the diagram of the thermodynamic system. So there's a system here, diagram, then the boundary. Here is the boundary, and then the surrounding. Outside the boundary is the surrounding. So the example of the uh, thermodynamic system is the piston of the machine. So this is the cylinder and gas inside, and this is the boundary. So this is the surroundings. So what is the surroundings? So surroundings or environment is the mass or region outside the system, or it is the area beyond boundary. So that is meant by surrounding. So the next is the boundary. So boundary is the real or imaginary surface that separates the system from its surroundings. It can be either fixed or movable. So the next is the universe. The universe is comprised of the system and its surroundings. So we have kinds of thermodynamics here. So first kinds of thermodynamic is a non-flow system. Closed, it means this is the closed system. So also known as the control mass, is a system consisting of the fixed amount of mass. So and no mass can cross its boundary. That is, no mass can enter or leave a closed circuit. However, energy in the form of heat or work can cross the boundary. So remember that only the heat energy can cross the boundary of the closed system of thermodynamics. So here the example of the closed system. So we have the boundary here, and then we have the energy in and energy out. So this is the surrounding. So take note that the mass interaction is zero, because no mass can enter inside and can go outside, because this system is a closed system. So the next is isolated system. So before we are going to proceed the isolated system, so I would like to give the example of another example of a closed system. So another example of a closed system here. So here we have another example before we proceed to the isolated system. So I give example of this closed system. The contents of pressure cooker on a stove with its lid tightly closed and the whistle in the position is closed system, as no mass can enter or leave the pressure cooker, but heat can be transferred to it. So that is the example, another example, my example of the closed system. So the other uh, type of thermodynamic system is isolated system. So what is isolated system? So isolated system is the system in which neither mass nor energy is allowed to cross the boundary. So what is mean this one? So here the diagram, the example of isolated system. So first, in isolated system, so no heat across boundary. So because isolated. So the next is no work across boundary. No heat. First no heat across boundary, and the next is no work across boundary, and then no mass flow across boundary. So everything cannot enter in this isolated system. So here is the surroundings here and the system boundary. So that is the isolated system. So let me give first the example of the isolated system. So example of the other example of isolated system is the a perfect insulated rigid closed vessel is an example of isolated system. It's neither mass nor energy can enter or the system. So it is isolated, perfectly isolated. So no one can get inside. So the next is the the next system is an open system. So open system, also known as control value, a volume, is a system which mass is allowed to cross the boundary in the system. Transfer of mass as well as boundary or energy can take place across its boundary. So this system, we can enter any uh, uh, anything like energy can in and then can out, and also the mass can in and can out. So that is the example of the open system. So both mass and energy interaction, so can get out or can get in and can get out of this open system. So take note, if the inflow before that I gave other example of the open system. So like the stove, example stove would be an open system because the heat and the water before can be lost to the air, and a closed system on other hand can exchange only energy with the surroundings, not matter. So this is the other example of the open system. So if the inflow of the mass is equal to the outflow of mass, then the mass in the system is constant, known as steady flow system. So the union of the system and surrounding is termed as universe. So universe equals system plus surrounding. So before we end, I give example about the thermodynamic system. So here the example. So first, uh, I give example. I solve this problem. Example. So first, calculate the change in the internal energy of the system. If 300 joule of heat energy is absorbed by the system, if the 400 joule of work is done on the system. Take note that the work is done on the system, meaning to say on the system is positive. And then if work negative by the system. So now we use this delta U equals Q plus W. Q means heat, W means work. So delta means change, then U means internal energy. So that's the system. So Q is equals to equals plus indo. It means going in, side. Then Q equals uh, exo means going outside, out out of the system. And then Q heat equals positive 300. And then here is the uh, W equals positive 400. So now we are going to add EU, delta U is equals to 300 joules plus 400 joules, because the all the is positive. So that's why we are going to plus this one, positive 700 joules, the change of internal energy of the system. So the next is example is the system releases 700 joules of the heat energy and 300 joules of the work is done by the system. Calculate the change internal energy of the system. So meaning to say, remember that the system here is negative because the joules here inside is going outside. So the 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 joules here, the work here is, the sign is negative because this one is going out. So once that the system is by the system, meaning to say the sign is negative, so this one is going out, then the surrounding is positive. So 700, negative 700 joules going to outside, that's why the surrounding is positive. And then 300 negative joules in this on the system, then by the going to the going out going to surrounding is, the sign is positive. So that's why we are going to, in the surrounding we are going to give the plus sign, positive sign, because the energy or the work is done on the surrounding is positive. So now the delta U equals to Q plus W is equals to negative 700 plus negative 300 equals negative 1000 joules on the system. So that's all, sir.